up here at the top it says no PEC. That's fine, it's just a simple drill cycle at this point. We'll talk about that in a minute. We've got our tool selected. Come down here and type in, what is this? A little note for yourself or the guy running it. I'm going to type in spot drill bolt circle. It can be as short or as long as you want it to be. This will show up in the program so that when the tool pass starts, you can recognize it as, okay, this is what's going to happen next.
I'll just catch up with you tomorrow.
Taking off?
Yeah.
Yes.
All right, thank
Yep. See you at 7?
you. Yeah, 9ish.
All right. Have a good night. Good luck with the top.
All right, thank you.
Yeah. Okay, so I'm going to skip the holder, I'm going to skip the stock, I'm going to go right to cut parameters. So remember we look at tool, cut parameters, and then linking parameters. These are the high points along our trip. So we go to cut parameters. Mentioned a minute ago I talked about no PEC drill cycle. That's up here. That's controlled with this drop down button right here. So if I had wanted to do a deep hole, I can't do it all in one shot. I'm going to want to PEC drill it. So I would choose PEC drilling. Or if I wanted to tap, I'd choose tap. Now some of these you'll have to find out what the specifics are on your machine at your shop. Because notice this just says tap, and this says rigid tap. Okay, so the software that converts what we've drawn into code, the post-processor, is usually set up for each machine specifically, and some machines require a preparatory code prior to tapping, so it's actually a 2-line of code. We have learned at this point how to write a single line tap code, and that's what the Haas will run on. But this is, you may choose rigid tapping, and again, with any of these, especially the tap cycles, you're going to want to go in there and look at your code when you post it, and do some calculations and try to figure out if the feed and RPM are proper. If you can imagine, if your RPM was exceeding the capabilities of the physical capabilities of the machine to move fast enough, what do you suspect would happen? So basically, the RPM is moving faster than the feed can keep up.
Yeah, it'll break.
No, it didn't actually break. It bored. It cleaned out the hole. It basically bored the major diameter of the tap. And we found that out because theoretically, if you use feeds and speeds, you look up aluminum, 700 surface speed. Well, that's 27,000 RPM or something. So the student says, well, I got a 6,000 max RPM, so we did the calculations proper to a half 13 thread and ran the cycle. The tap cycle was proper, but the machine just couldn't move fast enough. And so that motion of spinning as it went down and up basically just bored out the hole, which was kind of curious. What we'll do is we'll run it slower with the speeds and feeds like we talked about back in 203. So we want to have this at just a drill counterbore selected because we're just going down and back up. Yeah. And what else do we want to look at? We'll go down to linking parameters. This is the one that we change and have everything on absolute. Turn on our clearance, absolute. Everything's absolute. Now our depth, I'm going to start kind of shallow. I'm going to go minus 10 thousandths. And top of stock is 0, retract is our 0.2, and 1 for clearance above the part. Now what you'll want to do is run the spot drill cycle just like you did on your bench block, or would have done on your bench block, and witness the little marks, and then you can come back into your program, reset it, retract the tool, go into your length offset wear, and drop it down another 10 or 20 thousandths and rerun it. Okay, the idea here is we're just going to witness the top of the part. Just give this little marks on the top to just a visual verification. Are we on where we're supposed to be? Now, if hold up just a sec, watch what happens now. If I just click now, I'm done, and yours will come up like this. I'm going to click on back plot. If I look at it from the side, look how far the tool is retracting every time it goes in. Now there's a difference between proving out a program and optimizing it. You can help to optimize your tool path a little bit here. If with your tool path still open right here, see this little underneath the clearance, it says use clearance only at start and end of